Good morning. This is Notes, Unit 4, Day 5. We're going to go over the other 3 ways to prove triangles are congruent. This one is angle, side, angle. Remember, we need at least 3 colors. So this is angle. There has to be 2 angles, and then the side that's in between the 2 angles. So this order does matter. The included side. So if maybe B is equal to R, angle B, I can name angle B with 3 letters. Remember, B has to be in the middle. Maybe ABC is congruent to angle R, or HRT. That is, an angle is equal to an angle. Also, my other angle has to be equal to my other angle. Angle C is ACB. Remember, the C has to be in the middle. Is congruent to angle T, which we can say is HTR. These are my 2 angles. The side has to be in between them. Do you see the side connects these 2 angles? And this side connects these 2 angles. So this is side BC. We name a side with 2 capital letters and a line above it. It's congruent to side TR. Then triangle ABC will be congruent to triangle. A is the one without any congruencies, so that's H. B has the blue mark, so that's R. And then C has the green mark, so that's T. Remember, the order does matter. Let's look at how we would use this in a proof. These mean that my lines are parallel. But we know if we have these parallel lines, LM, line LM, is parallel to line NO. This is given. But what can I get from having parallel lines? Well, I can get equal congruent angles. I can get the alternating interior angles. Remember that their alternating angles are the ones that touch this line. I can't use this angle because it's not touching my line. But this one is alternating to this angle. So I can say this angle M, or LMN, is congruent to angle N, but not all of N and not this part of N. So I have to name it with 3 letters. ONM. These are congruent because they are alternating interior angles. Angle apostrophe S for angles. Also, I know that this line is parallel to this line. So NL is parallel to MO or OM, whatever order you want. And this is given. They give us that. They plug it into the directions for us. But since we have these parallel lines, we also have alternating interior angles. This one is just the top part of N. That's why we have to name it with 3 letters. The top part of N is LNM. Is congruent to the bottom part of M, which is OMN. Because these are also alternating interior angles. Now, remember that we can almost always use the reflexive property or the vertical angles. In this case, we only have the reflexive property to use. So we're going to say this side that they're sharing is their common side is equal in both triangles. So NM is congruent to NM because of the reflexive property. And that's all I need to prove my triangles are congruent. I have, remember we start where there's no congruencies, and I can go clockwise clockwise or counterclockwise. And I'm going to go cover up the top triangle with your hand. I'm going to go angle, side, angle, or I could have gone the other way. This is an angle, side, angle. So I'm going to restate what I'm trying to prove, that triangle NLM is congruent to triangle MON, but my reason is always going to be one of those 5 reasons, like angle, side, angle, 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 side, 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 angle, side, or HL. These are my 5 reasons that we're going to use for the ending proof. And this one is going to be angle, side, angle. Is it possible to prove the triangle congruent by angle, side, angle, specifically by angle, side, angle? We cannot use anything else, okay? So if these are my parallel lines, then these are my alternating interior angles. And if these are my parallel lines, and this is my transversal, then these are also my alternating interior angles. And then I have this reflexive property almost exactly like we have in the one above. And this is an angle, the side in between it, the very next angle. So we can say yes, this one is, we can prove congruent by angle, side, angle. We have to put them in order. A, D, C. Just look at this bottom triangle. A is the one with the blue congruency mark. In the top triangle, which one has the blue congruency mark? D. Then we went to D, which is in the bottom triangle, the one that has the purple congruency mark. On the top triangle, the one that has a purple congruency mark is A, and then the last one is B. That order does matter. Remember, this order matters. So they're telling us that this angle is equal to this angle. I know that if this is a 90-degree angle, then this one will be a 90-degree angle because this forms a straight line. So these 2 angles are equal. But then we have the next side. Is this side in between my 2 angles? No. So we cannot prove that they're congruent by angle, side, angle. Remember, the side has to be in between my 2 angles. Let's look at this one. We know that this angle is congruent to this angle because they give us that. This whole side is congruent to this whole side because they give it to us. There's one more thing that we can assume is congruent are these vertical angles. But on my side, is my side in between my 2 angles? It has to be between my 2 A's. This is an angle. This is a side. It has to be K. So no, these are not going to be congruent by angle, side, angle. This is my angle. This is my angle. It had to give us this side, HI, or JH. We can also prove that they're congruent by angle, angle, side. This angle is congruent to this angle, so angle A, but I cannot name it with A. I have to use 3 letters, BAC or CAB is congruent to L, or angle CLO. That's an angle. The very next angle is angle C and angle O. Remember, I have to name this with 3 letters, and C has to be in the middle. So I'm going to say angle ACB is congruent to this angle, which is angle COL. And then, so angle, angle, the very next side. We have this side, BC, is congruent to this side, CO. So this one would be angle, angle, side. Okay, congruency statement, triangle ABC is congruent to triangle. A is the purple congruency, so that is congruent to the purple congruency, which is L. Then they told us to go to B, but B is the one with no congruencies. The one with no congruencies is C, and then the last one is going to be O. We have a proof. It says given DF is parallel to PL. So I'm just going to plug in what parallel means, that these are my parallel sides. This does not give us a congruency. This just helps us find our angles, or we're going to be able to imply something from this. So D to F is parallel to P to L, and it tells us that F to H is congruent to L to H. So this side, F to H, is equal to this side, L to H. That's something that we need. From these parallel lines, well, I'm gonna write it in here. DF is parallel to PL, and FH is congruent to LH. So I plugged them into my diagram. I'm going to write it in here. My reason is given, always. We start with what is given. From what is given, I can conclude that this angle is congruent to this angle. Because these are parallel lines, and this is my transversal, and these are alternating interior angles. So I can say angle DFH is congruent to angle PLH, because these are alternating interior angles. There's one more thing that I can just assume from this diagram. Since these triangles are intersecting, then I know that these opposite angles are congruent. To name this angle, I have to use H as my middle letter. DHF is congruent to this, has to be my middle letter. PHL, maybe, angle, PHL, because these are vertical angles. My last step is always to rewrite what we're trying to prove, which is triangle DHF is congruent to triangle PHL. And my reason is angle, side, angle. Well, this one's going to be angle, side, angle. All right, let's see if we can prove these are congruent by angle, angle, side. So this angle is congruent to this angle. We know my vertical angles are congruent, and they are giving us that this side is congruent to this side. So this one would be angle, angle, very next side. Very nice. So you say yes. I want you to write your similarity statement, right? Remember, the order matters. This line is parallel to this line, so I have these alternating interior angles. I also have these alternating interior angles if I wanted to. And then I have this side is congruent to this side. That's what the little dash mark means. It means that these are congruent. So I have angle, angle, side. So yes, this one can be proven. And I want you guys to write the similarity statement. I want you guys to check this out. These do not prove that triangles are congruent. But we do have one more. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So the hypotenuse is AC, has to be congruent to DF. That's the hypotenuse. And leg BC is congruent to leg EF. You guys see it's a right triangle, which means it has this 90-degree angle. Then these two triangles are congruent. Remember, the congruency or the order matters. A to B to C. A is the one with no congruencies in the red. No congruencies in the red is D. Then they told us to go to B, which is the right angle. Our other right angle is E. And then they told us to go to C, which is in between the red and the purple. Between the red and the purple is F. DEF. Let's try one more proof. I want to try this one. So we're trying to prove that this triangle MNQ is congruent to this triangle QPM, this top triangle. I'm going to start with what is given. angle N and angle P are right angles, and this reason is given. So it's a right triangle. Also, I'm given that this side is congruent to this side. And this is also given. They give you this. They write it in the diagram for you, but it's given. Now, something that's not given that we can almost always conclude is that any common side is equal in both triangles. If they're sharing the side, it's equal. MQ is congruent to MQ. And this is because of the reflexive property. Just like you're looking at yourself in the mirror as your reflection, the reflexive property is when something is congruent to itself. Okay, I have enough information to prove these triangles are congruent. Because they are right triangles and we have the hypotenuse and a leg in each triangle, I can say that these two triangles are congruent. Triangle MNQ is congruent to triangle QPM by the HL postulate. I want you guys to try the next one. If you have any questions, please let us know. Have a great night.